The vertical turret lathe operator must be skilled to produce the accurate work required for modern machine parts. This operation sheet details the procedures required for machining the crankcase nose section of an airplane engine. This part is semi-finished, and the final or finishing cuts will be held to very close tolerances. Special measuring instruments for these final cuts are listed on the operation sheet. In addition, the usual measuring tools must be used. Mass production work on castings of irregular shape, such as this one, requires a specially prepared fixture to hold the work on the table. This particular fixture has been accurately machined and fitted to the table so that it will hold the work level and true. For proper alignment of the work, fixtures must be kept free of chips. This casting is fastened to the fixture by means of an adapter plate. Holding work in fixtures varies from job to job, but the work must always be held securely. The casting is of a magnesium alloy. The jacks on the side support the upper rim against the pressure of a cut. For precision cuts, the work is trued by a dial indicator. This is fixed to any convenient and rigid part of a machine. Here, an extension is used so that the casting can be trued on the ID. The feeler extension is moved until it touches the rim with a gentle pressure. Although the fixture is designed to center the work, the trueness should be checked since castings often warp in storage. The indicator dial, graduated in thousandths of an inch, is turned to 0. Now, as the work revolves, any deviation from true center is measured by the dial. Here the work is true within 1/2000th of an inch. The operator is now ready for the first cut. The tools are checked with the operation sheet to be sure that he has the right ones. At the same time, he makes certain that they are sharp. The first cut is to semi-finish face the flange and turn a shoulder. A specially ground tool is selected. This operation can be done conveniently with the side head as shown in this animated diagram. The depth of the cut is calculated from a reference point. To establish this point, the operator holds a thin piece of paper under the tool and lowers the tool until a slight drag is felt. A clip is set on the vertical index dial to mark this point. The height of the flange from the fixture is now 9 1/8 inches, or 1/32 of an inch oversized. He therefore lowers the tool 1/32 of an inch by counting off approximately 31 1/2 thousandths from the clip just set. Then the clip is advanced to the new position to mark the depth of the first cut. The cutting speed for magnesium is approximately the same as for aluminum, so the gears are set at 200 RPM, or the highest speed of the machine. Since this is a finishing cut, a fine feed of 11 thousandths is used. No coolant or lubricant is used on magnesium. The chips are highly inflammable. Friction from a dull tool or any spark may set them afire. Never attempt to put out a magnesium fire by means of water or any liquid extinguisher. Use sand to smother it. A bucket of sand must always be kept at hand when machining magnesium. When the tool approaches the OD of the shoulder, the operator disengages the power feed and uses the hand feed for the remaining distance. As a guide for the next cut on the OD of the shoulder, the operator sets a clip on the cross-feed index dial. Note how the operator raises and backs off the tool to prevent it from scratching the surface. The flange is now of the proper dimension, 9 3/32 inches from the fixture. The operation sheet shows the dimension of the OD of the shoulder to be 19.310, 19.306, a tolerance of 4 thousandths. The operator makes a rough check with the scale and finds that approximately 50 thousandths of an inch must be removed. He has a snap gauge especially made to check this diameter. Starting at the clip formerly set when the tool reached the OD of the shoulder, the operator decides to take about 15 thousandths in the first cut. He advances the clip 15 thousandths on the horizontal index dial. After this trial cut, the snap gauge is tried and the operator finds that more stock must be removed. He advances the clip another 8 thousandths. This time he continues the cut down to the flange. Again, the power feed is disengaged and the face of the flange is approached with the hand feed. When the maximum dimension of the snap gauge is used, it shows that the OD is still oversized. Five thousandths more are removed on a side. Remember that each graduation on the side head dials represents a tool movement of 2 thousandths of an inch. Since there are no automatic stops on the vertical turret lathe, the operator must check each cut. Trial cuts are taken and checked until the final dimension of the shoulder is reached. Care has been taken to avoid the possibility of cutting undersize. The maximum or go button of the snap gauge does not slip over the largest diameter. The operator decides on another cut of 2/1000ths. Notice the highly finished surface resulting from a very fine cut, a properly shaped tool, and a very fine feed. The go button of the snap gauge now slips over the highest point of the OD. The work is now 19.310 or less. The no-go of the snap gauge does not slip over the OD, therefore the work is between 19.310 and 19.306, or within the tolerance permitted by the blueprint. This outside diameter cut will also be made by the side head. Tools used to machine magnesium differ in shape from those used on other metals. Again, the paper drag method is used to fix a reference point for calculating the distance from the flange to the point where the turning cut is to end. Since the height from the flange to the pad is going to be 2.125 inches, the operator now lowers the tool that amount, measuring the movement on the vertical index dial. When the clip is reached, the cut is completed. He now prepares for the OD cut by measuring the outside diameter. The vernier caliper is adjusted to the OD until a slight drag is felt. It shows the dimension to be 21.565 inches. To cut the OD to the necessary dimension, 21.545, the operator will remove 0.010ths on the side. The trial cut is made and the vernier now shows 21.545. He is now ready to continue the cut. On the vertical turret lathe, two heads can be used at once. The inside diameter can be bored and the outside diameter can be turned at the same time. For this particular cut, an especially tipped boring tool is mounted in the bar and tightened by means of set screws. An inside micrometer is used to check the ID. It shows that the dimension is now 17.757 inches, 43 thousandths to be taken off on the diameter, 21.5 thousandths on the side. A trial cut must first be taken to avoid the possibility of cutting undersize. The ID is now 17.800 inches as called for in the operation sheet. When no tolerance is shown on the operation sheet, it can be assumed to be plus or minus 5 thousandths of an inch. Check dimensions frequently with the operation sheet. Both cutting tools are now brought into position. A clip is set on the horizontal index dial as a guide for future boring cuts on other castings. The clip previously set on the side head enables the operator to return the turning tool to the position of the trial cut. When the tools are in position, the table can be started and the vertical power feeds for both main head and side head can be engaged. When the boring tool reaches the end of the cut, the operator disengages the power feed and backs off the boring tool. The OD cut with the side head continues. The cutting action is here shown in slow motion. When the OD cut approaches the end, the operator disengages the power feed and uses a hand feed down to the pad. The clip, which was set for the depth of this cut, serves as a guide. Notice the slipping action of the clutch. The operator uses it to slow down the table because this tool is a finishing tool and care must be taken when it moves into the rough, unfinished part of the casting. Efficient production requires careful planning of setups to take full advantage of the machine. The top flange must now be finish faced to give an accurate dimension from the shoulder face to the top of the flange. To determine this dimension, a special flush pin gauge is provided, which is especially made to check the tolerance allowed for this cut. The flush pin gauge is placed on the flange and feeler gauges are used under it to determine the amount of stock to come off. Feeler gauges of a thickness of 0.08 are needed to bring the pin flush. This is the amount of material to be removed. The flush pin gauge is one of the methods used for checking work within given tolerances. When the flange has been cut, the flush pin gauge is again tried. The pin now shows that the top flange is within the proper tolerance. For this particular grooving operation, a grooving tool ground to the exact dimension of the groove itself is provided. In order to find the proper distance from the ID to the edge of the grooving tool, the radius of the ID is subtracted from the radius at the center of the groove. 1/2 the width of the grooving tool is then subtracted from this figure, giving the desired measurement. The tool is shifted by the horizontal hand feed wheel until the exact location is found. Because the depth of the groove is going to be exactly 1/2 inch or 500 thousandths, the operator makes a very slight cut with the grooving tool and sets a clip at this point. A vertical feed of 1 revolution on the dial back to the clip gives the proper depth. The jacks on the side support the upper rim against the pressure of a cut. For precision cuts, the work is trued by a dial indicator. This is fixed to any convenient and rigid part of the machine. Here, an extension is used so that the casting can be trued on the ID. The feeler extension is moved until it touches the rim with a gentle pressure. Although the fixture is designed to center the work, the trueness should be checked since castings often warp in storage. The indicator dial, graduated in thousandths of an inch, is turned to 0. Now, as the work revolves, any deviation from true center is measured by the dial. Here the work is true within 1/2000th of an inch. The operator is now ready for the first cut. The tools are checked with the operation sheet to be sure that he has the right ones. At the same time, he makes certain that they are sharp. The first cut is to semi-finish face the flange and turn a shoulder. A specially ground tool is selected. The vertical turret lathe operator must be skilled to produce the accurate work required for modern machine parts. This operates level and true. For proper alignment of the work, fixtures must be kept free of chips. This casting is fastened to the fixture by means of an adapter plate. Holding work in fixtures varies from job to job, but the work must always be held securely. The casting is of a magnesium alloy. The operation sheet details the procedures required for machining the crankcase nose section of an airplane engine. This part is semi-finished, and the final or finishing cuts will be held to very close tolerances. Special measuring instruments for these final cuts are listed on the operation sheet. In addition, the usual measuring tools must be used. Mass production work on castings of irregular shape, such as this one, requires a specially prepared fixture to hold the work on the table. This particular fixture has been accurately machined and fitted to the table so that it will hold the work